So each of the groups that you began today with were given 4 elements and a binary operation on that set of 4 elements. And we're asked to construct a multiplication table. And these multiplication tables are up around the room. What I would like for you to do in these groups is to circulate. So start at one of the posters. So maybe I'll have groups 5 and 6 start with this poster over here. Groups 7 and 10 start with the one over here. And the other 2 groups that I didn't mention, one group start at this poster up there, so I guess group 8 and group 9 start at the poster in the back corner there. And your job is, as you visit this poster, explain how this multiplication table works to the other members of your group, if you worked on it. If you didn't work on it, just put up your hand, I'll come over and I'll try to explain it. But most of these you should have somebody in your group that worked on. So the discussion questions I want you to be thinking about from this assignment are, as you visit these different posters, are there elements that you can find in the sets that you've depicted here that behave the same as one another across all 4 different posters? So if you look at questions 1 and 2, I'm asking you to fill in the blank. Blank in G1 behaves exactly like blank in G2, which behaves exactly like blank in G3, which behaves exactly like blank in G4. Right? So find an element in each of these 4 structures that behaves the same, has the same role within its multiplication table as the corresponding elements in the other groups. So see if you can come up with 2 such examples as you're browsing around with your group. So you had 4 different groups, got 4 different sets of objects, 4 different binary operations, made a multiplication table. Here they all are. And the first question I asked of you as you were doing your gallery walks is to find me an example of an element in each of these 4 structures that's playing the same role within its multiplication table. Did your groups feel like you found an example in each case? Nodding? Okay. So let's start with the first table, the table for G1 over here. What was the element here that behaves the same way as other elements in other groups? 1. What was special about 1? Why was 1 behaving in a special fashion? How could you tell?
It's like the identity.
Okay. The identity in what sense? How can we tell from this table that it is an identity? What does that even mean?
Well, 1 times anything gives you the anything.
1 times anything gives you the anything. When I multiply the complex number 1 by another complex number, it leaves that other complex number unchanged. How does a table tell that story? How can we tell what's the identity in this table?
The first row and the first column are the same as the things that you start with.
First row and the first column are the same as the things you start with. Very good, right? When I look at that first column and I look at that first row, each of them is just 1 minus 1, I minus I, which is exactly the same as the row and the column of the original elements themselves. So if that's my special element in this first structure, what's the special element here when the elements are matrices? So group number 2. What corresponds? What's the corresponding?
The D matrix.
The D matrix. Because if you look at the row or the column that has D on it, what do you see? What do you notice? They all say the same. A, B, C, D. A, B, C, D. Same thing with the row. A, B, C, D, A, B, C, D. Because when I multiply a matrix on the left or right by D, that matrix remains unchanged. All right, how about in the sets with symmetric differences example? What's our candidate for the identity here? The empty set. So when I take the symmetric difference of a set with the empty set, it leaves that set unchanged. Right? And again, we can see that in the structure because that row and that column of the multiplication table are exactly the same as the original row, original column. And finally, for the elements that are part of the symmetries of an octagon, what's our candidate here? What acts the same? Yeah. I. The identity symmetry, which doesn't throw us for too much of a loop after all. What does the identity symmetry do? It picks up the octagon and it sets it right back down in the same spot we found it, right? Of course, if I do that and then I do any other symmetry, the net effect is just going to be that other symmetry. So there are 4 elements that seem to have the same role across all 4 of these structures. Your goal over the weekend is to find a second element in these structures that plays the same role as one another in all 4 cases. And then also to see, again, discussing with the members of your numbered group on Slack, if you can figure out which one of these 4 examples doesn't belong. Okay. One of these things is not like the other. And your job over the weekend is to sleuth it out. Which one of these structures is actually different, fundamentally different than the other 3. And my caution here is not to get caught up in the specifics. If you're thinking about complex numbers, matrices, sets, symmetries, if you're thinking about those things concretely, you're thinking too hard. Instead, be thinking about the structure. Just think about what the multiplication table looks like, just the properties of the table, because that's what's abstract. Everything else is window dressing. Matrices, window dressing. Complex numbers, window dressing. Sets, window dressing. Symmetries, window dressing. They give us a lot of good examples to work from, but if we're trying to find similarities, the specifics need not to matter, and only the structure. So take a look at these tables with your numbered group over the weekend and see what you come up with.